Hi everyone, this week we are going to be learning about the mole. The mole is a new way of counting that we haven't done before. So we're going to be learning not only a new way to count our molecules, but we're also going to be learning about some new numbers. So it's kind of similar to how you go to the supermarket and you buy a dozen of something. So a dozen isn't actually a number, but it represents if you were to have 12 of something. So they have them different ways. You can also do measurements in, by count. Like you go to the store and you buy 10 apples. You can also do that by weight or by mass. That's why they have those scales at the store. And you can even buy them by volume, but you have to go to a big supplier for that. So there are lots and lots of different ways to measure these apples. And what we've become used to is the idea of a dozen. So if you were to have 1 dozen apples, that means you are holding 12 apples. But we like to be able to figure out an easier way to package up that number and make it so that everybody knows how many you are holding. You could also do something by mass. So a dozen apples is about 2 kilograms of apples. You could even do it by volume, but again, these are all different ways of saying the same thing. We're trying to say 1 dozen apples. There are just multiple ways of doing so. So knowing how the count, how mass and volume relate to one another, you can convert among those units. So it's important to understand that the first step you always want to take is to determine how they are related. So for example, you could have a dozen apples over 12 apples, or you could flip those over and be 12 apples in 1 dozen. You could also do it by mass, and that is our second example here. You have your 2 kilograms of apples over 1 dozen apples, or you could do it by volume. Notice here how you can put in any location your dozen of apples. You can put your other mass unit on the top or the bottom. It all is based on what answer you're trying to find in the next section. So for example, if you have the mass of 90 average apples, or you're trying to find the mass of 90 average size apples, if you have 1 dozen apples that has a mass of 2.0 kilograms. So originally this is going to sound really scary, but there are some steps that we can take to make sure that we get the right answer. Okay, here are your steps for figuring out our answer. So you're going to use these steps. You want to make sure that you are going to be writing these down in your notes, but these are the good steps to figure out how much how to convert between any unit of mass to any new unit we need to get to. So first of all, you want to underline the amount given to you. So let's look back at our answer, or our question here. The amount given to us is the mass, or the number of apples. The number of apples is what we are given. Step 2 says to circle what information you are trying to find. And so it's usually close to the word what or how. So what is the mass? So we're trying to find mass. Next is to write out all of your conversion factors. Now here it says that 1 dozen apples is equal to 2.0 kilograms. So from this information, we can determine that our conversion factors are 1 dozen apples over 2.0 kilograms, or 2.0 kilograms over 1 dozen apples. So that takes care of step 3. Number 4 says to begin with your given information. So our given information back here is, again, already underlined. It says 90 average size apples. Okay, I've changed our number to 96 just to make something even or easier. So we have 96 average sized apples. That's also known as 8 dozen. So we're going to start with 8 dozen. So we start with our 8 dozen apples over 1. And now we're going to, according to number 5, choose the correct conversion factor that cancels out our units. So if we have a dozen apples on the top, we must put the same unit on our next line, on the denominator. That cancels out our answer, or our units. So of our options, option 1 has a dozen apples on top. We wouldn't want that one. But option 2 has a dozen apples on the bottom. That will allow us to cancel out our units. So we will be using this conversion factor. So on the bottom, it will be 1 dozen apples. Now, these numbers do not need to match, only our units. And on top, we must put our 2.0 kilograms. Now, number 6 says to multiply your numerator and divide by anything in your denominator. So as long as our units cancel, because we have 1 on the top and 1 on the bottom of our fraction, we can multiply straight across and we'll be left with something in kilograms. So 2 times 8 is our 16 kilograms. So overall, 8 dozen apples would weigh 16 kilograms. Now we can do the same thing with something called the mole. The mole is something that is a specific number of particles that we always use the same number for. Just like how we know 1 dozen apples is 12 apples, we know that 1 mole is always equal to 6.02 times 10 to the 23rd particles. Now, this big number is also known as Avogadro's number. Avogadro's number is going to be that 6.02 times 10 to the 23rd. Now, the thing that we put after it, the unit that we put after it can be particles, formula units, atoms, or molecules. And based on what type of substance we are looking at, and also the question at hand, it will tell you exactly which one of these denominations we will use with our mole. So again, that representative particle is going to be a generalized idea, but we'll probably be talking about more specifically atoms, molecules, or formula units. Molecules are just your covalently bonded molecules, and your formula units are your ions. So for example, iron is going to be composed of iron atoms. Helium is going to be composed of helium atoms, but NaCl would be a little bit different because there are 2 different elements here, so this would be actually a formula unit since it is an ionic compound. 7 elements that exist as elements, but they are considered diatomic molecules. They have to be part of a group in order to survive correctly. So that would be hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Some people like to remember it using some sort of mnemonic device. My personal favorite is the following. So I like to remember them in this order. If anybody is a Harry Potter fan, a lot of times you think of the word Hufflepuff. Well, this is Hunklebriff. It's very close to the idea from Harry Potter, and it helps you remember those diatomic elements. Now, molecular compounds would be stuff like water and sulfur dioxide. Notice how these are molecules that are of different elements combined together to make your molecular compound. These molecules are always going to be from the right side of your periodic table. Ionic compounds, on the other hand, such as, say, calcium chloride, you're going to have 1 element from the left and 1 element from the right of your periodic table. Oops. So that helps you remember that those are going to be formula units. Thankfully, though, whenever you are doing your calculations, typically they will tell you what type of representative particle you are going to need. So overall, this mole is going to allow us to count the number of particles in a substance. This is important for making new solutions or trying to figure out how much of something you're going to make, so it's very important. Here's a table of going to kind of show you the different types of representative particles. It's not something to memorize, but it does kind of help you see the difference between something that is an atom, a molecule, an ion, and a formula unit. So there's lots of different options. Whenever you're converting between these number of particles and the moles, these are your two conversion units that you're always going to be using. So if you think back to our steps to finding out our apples, you want to make sure you write all your conversion factors in number 3. This is going to be the answer every single time because your conversion units never change. That's very nice. It helps us make things a little bit easier. So let's give it a shot. So we have magnesium. We're trying to figure out how many moles of magnesium is in 1.25 times 10 to the 23rd atoms of magnesium. You will need a calculator, so make sure you grab that. So first of all, we're going to underline what is given to us. That's number 1. And we're going to circle exactly what we want. We're then going to write down our conversion units. So we know that 1 mole is equal to 6.02 times 10 to the 23rd. And for this one, see how it says the word atoms? So we're going to write the word atoms down here. Our other option for our conversion unit is to write 6.02 times 10 to the 23rd atoms over 1 mole. Now we're going to start with what we are given. We are given 1.25 times 10 to the 23rd atoms over 1. And now we have to pick which conversion unit will cancel out our atoms that are on the top. So since this conversion unit here on the right has atoms on top, that wouldn't work because the way that we cancel is to have the same thing on the top of a fraction as we do on the bottom. So that won't work. However, our first one here on the left will, since our atoms are on the bottom. So we'll take this and we are going to rewrite it exactly how it is shown. And once we get to the unit that we want, that we have circled up at the top, we're all set because everything else cancels. So once it's all said and done, your answer would be 0.28 moles of magnesium. And this is also taken, it shows you the same steps in your notes that are uploaded online. So now we can do the exact opposite. If you're given how many atoms, you can go all the way to moles. You can also go from moles to atoms. So if you want to determine how many atoms are in a mole, you just did that. You just have to write down your conversion unit, use those same steps. You must know how many atoms are in your compound of this specific chemical formula. So for example, this is just like counting for balancing chemical equations. In the formula for carbon dioxide, you have carbon, and there is 1 of them, and oxygen, you have 2 of them. So we're going to use the same steps as before when we are counting our numbers or converting between molecules and atoms. However, we are going to also add 1 extra step. All right, we want to figure out just how many of one type of atom in a question. So we have to figure out how to go between the idea of atoms to moles to a specific atom. And we're going to make 1 extra video just to show you that one, and it's going to take you through each step. Please go to the next video now.